Hi, so welcome to the walkthrough video for question 1 on lab 7, subsequences. So before we look at the problem, I wanted to mention something about the structure about these walkthrough videos, especially for this lab and also future labs. And so the idea is that I'll be splitting the explanation into two portions. So the first portion I'll talk about like the ideas you can get from just reading the problem statement and looking at the doc tests. And the second part will be turning those ideas I mentioned into the programming implementation. And so the reason why we're going to split it like that is so that when you are faced with these similar problems in like an exam or in the future, you are able to generate these ideas. And generally, turning the ideas into programming implementations requires much less work, but the act of acquiring these ideas from just looking at the problem statement often requires more experience. And so hopefully by looking at these walkthrough videos, you'll gain that experience. Cool. So let's look at the problem first. This problem subsequences is split into two functions that we need to implement. And so the first function is relatively simple since we only have one line. But let's look at the problem. So what we want to do is we want to well, what we're going to take in is a item. So that could be an integer, a string, etc. Doesn't matter what it is. It also takes in a nested list. So a nested list is what kind of looks like this, is a list of which every element inside are also lists. And so what we want to do here is we want to insert this element in the front of all these elements within the nested list. So here's a very good example. We have a nested list and we run the function. And we want to insert the element 0 in the front of all this lists, and we do. So this empty list becomes 0, the list 1, 2 becomes 0, 1, 2, and the list 3 becomes 0 and 3. Cool. So the ideas we have here, first of all, is we notice that what we want to do here is we want to go through all the elements in our nested list, right? Because we see that regardless of which element it is, we add or we insert the item in front of all the elements in our nested list. So we need to find a way to go through all the elements of our nested list, right? That's the first idea. The second idea is, well, after we go through all the elements, we need to somehow turn this item. We need to turn this item into a list, right? Because if we don't turn it into a list, we can't exactly stick it on. So we have to turn it into a list, and then we add it to these lists. Just add it in the front, and then we're done, right? So those are the two ideas we have. So how do we turn that into our code here? So first, thinking about how we go through items of a list. So there, hopefully, I think we've covered 3 main approaches of how we do that. First of all, we could think about a for loop, right? So we could do for x in, say, NL being the nested list, right? And so an x will go through and be each of the elements one by one. And after that, we could just add the item to x. That's a good idea. But the issue with that is that we don't have the space for that. We only have one line here. So that won't work. And the while loop also falls for a similar issue because the while loop also requires more than one line, and we only have one line here. So the final approach we have is using a list comprehension, right? And the list comprehension is great here, not only because it fits in the line, but it also perfectly matches the output we want, right? Because notice that the output of the insert function is also a list, and and so list comprehension here is perfect. So let's write some of the code first. So we're going to return a list comprehension, and well, this comprehension follows the structure of, well, some expression here for, and so we want to go through all the elements of the list. So sorry, of the nested list. So for x, right, this variable doesn't really matter. For x in nested list, right? And so x is going to go through and be each of the individual elements inside the list. And so what is the second thing we talked about? Well, what we want to do now is we want to somehow turn this item into a list and just stick it in front of the x. And so how do we do that? Well, a great way of turning the item into a list is simply just to put it inside a list, right? So now item is a list of which only has one element, and the element is just item, and we can just add it to x. And we know that x is already a list since this is a nested list, and each of the elements in a nested list are also lists. So we have a list plus a list, and we will get over here. So in this example here, 0, right? So we turn 0 into a list. So a list with 0 plus the empty list, we get 0. That's good. Over here we have x being 1, 2, and the item being the list of just 0. We add it together, we get 0, 1, 2. And the same thing over here, and we get 0 and 3. Perfect. So we're done. We're done with this part. Cool. Let me just remove the space. Okay, so now we can move on. So moving on to the next part of defining the larger function here of subsec. And uh, let's read through the problem statement first. So what we want to do is we get an input of a list, and we want to return a nested list. And what the nested list is supposed to do is it's supposed to list out all the possible subsequences of S. And so what a subsequence is you can kind of think about it as being like a subset. So I could like choose certain elements from 1, 2, 3 here. So I could either choose just one, I could choose 1 and 2, I could choose all three, 1, 2, 3, or I could choose no elements like over here. And so over here we have a example of all the subsequences of 1, 2, 3, right? And so the ideas we have here is that, well, we want to have a way to like to get all the options, right? So we want to consider the option of just choosing one, consider the option of just choosing two, consider the option of choosing all three, consider the option of just or just not even choosing any of them, right? So we're going to consider many options, right? Or what we could also phrase it as is being exploring the possible ways of selecting the elements, right? And so the terms exploring the options or exploring the possibilities, hopefully that points towards some type of tree recursion. And if we look at the skeleton here, we also notice that the way this function is structured for us also resembles some type of recursive approach, right? Where we have an if or conditional statement here, and then the else being here. And we see that, well, if we have like a conditional statement before our, hopefully like a recursive call here, so this might as well be a base case. And so those are just some ideas, right? And so it's not a hard and fast rule where we have to do recursion here, but it is a good first attempt, or it's a good somewhere to start off, right? So since we're dealing with tree recursion here, hopefully you've covered this in discussion, but generally when we have tree recursion, the recursive calls are how we explore our different options in the tree recursion. And so what are the options we have here? A lot of the times when we're thinking about tree recursion problems, a very common option we have is this idea of inclusion and exclusion, right? And so an example of that would be the example from lecture of partitions, right? So in the example, hopefully remember that in partitions, what we do is we either include the largest partition or we don't include the largest partition, right? And so the sum of those two possibilities is the sum of all the total possibilities of the total partitions. And so we have the exact same situation here, right? So let's just pick one of them. Let's say the first element here, right? So in the example of 1, 2, and 3, let's consider the option where we don't choose one. So if we don't choose one, we only choose from the elements of 2 and 3. Well, we have the options of either picking no elements altogether. We could just pick 2. We could just pick 2. We could pick both 2 and 3, or we could just pick 3. Right? How about the options of including one? So if we include one, what we have is we could either just have one, we could have 1 and 2, we could have all 1, 2, and 3, we could have just 1 and 3. And yeah, so those are the 4 possibilities as well. And note that those 2 possibilities combined give us the total possibilities. So those are the ideas we could have for the recursive calls. Let me write that down. So recursive call is going to be, well, include first element. And so it doesn't matter if it's the first element, the last element, that doesn't really matter that much as long as we are isolating an element and we're considering the possibilities of including it or not including it, right? And the only reason why I chose the first element is because, well, it's easier to isolate, right? Because we can just get it by indexing it, right? We just do index 0, and we could exclude it by just using a list slicing, right? So exclude first element. Okay, so let's dive a little deeper and think about, well, how do I write these calls? So let's consider the possibility where we don't include 1, right? And so we have just 2 and 3. Well, this is easy because we can just count it out. We can just list 2, 3, 2, 3, or none, right? So there's 4. But what if I give you 100 elements? What if I give you 2,000 elements, right? There's no way for you to just count out all the possible options or the possible subsequences we have if we don't include the first element, right? So for example, if I give you 2,000 elements, you don't include the first element, and you want to figure out the number of subsequences you have in the rest of the 1,999 elements, right? So you can't list it out. And well, won't it help if we have a function that helps us calculate the number of subsequences we have in a list of a certain length, right? And in fact, we do. And that is precisely the function we're defining, a subsequence. And so that should hopefully remind you something of a recursive call. So what we want to do here, well, if we include the first, let's think about the excluding case first. So if you want to exclude the first element, well, what we want to do is we want to call subsequence on, so again, this is still pseudocode. So we want to call subsequence, and we want to call it on, S, right? We want to call it on the list S, but we don't want to include, the first element. So we want S, but without first element, right? But how about if we include the first element, right? If we include the first element, well, if we look at the example here, actually, I'll just list it out so it makes it looks clearer. So example of 1, 2, 3. Right, so if we exclude the first element, that will be just calling it on 2 and 3. And so this will give us 2, 3, nothing, or 2 and 3. Right, how about the including the first element? Well, same thing, but we could write it out as well. So we could have 1 and 2. Right, we could have 1 and 3. We could just have 1, or we could have 1, 2, and 3. Right, and we say that, well, what's happening here is that the cases where we don't include 1 actually looks very similar to the cases where we do include 1, right? And what happens here is that, well, all we're really doing is that we're considering the options of not including 1, but we're just adding 1 to the front of it, right? And these two cases are added together give us the total possible, or all the possible combinations, or all the possible subsequences, right? And so if only we had a function that lets us insert an element inside a nested list, and we do, right? And that is the function we defined up here. So what we can do is we can call insert into all onto, let's give me some more space here, onto what we're going to call it. We're going to call it onto, we want to call it onto, well, the first element, right? Because that's the element we want to insert. So first element. And well, what is the nested list we want to call? The nested list we want to call on is precisely the output over here, right? And so we want to call it on this output. So it's going to be the, and we also want to call it on the case where we exclude, right? So that is a lot of pseudocode, and I think it's time we turn that into the actual code here. So since we use this idea of excluding the first element twice, right? We use it over here once, and we use it over here once, right? I think it's a smart idea to just give it a name, right? Since we're going to use it twice, let's give it a name. So let's call it subset, right? And well, what is this subset now? Let's think about, let's turn this into a Python. So the subset is basically the total number of subsequences, right, where we exclude the first element. And so how we get that, remember, is that we use this recursive call. We recursively call the subsec on, well, what do we want to call it on? Well, we want to exclude the first element, right? So how do we exclude the first element? We have this very convenient list slicing, right? So list slicing allows us to get a certain part of the list, and list slicing always returns a list. So that's very good. And this basically we run from index 1 all the way to the end. So we exclude the first element. Perfect. So over here, we have our variable defined here of subset. And now we only have one line left, right? So are we able to combine these two recursive calls in one line? Now, first of all, let's think about how we want to combine it, right? The subsec function returns a integer, first of all, right? And the subsec function returns a nested list. Sorry, it returns a nested list. And what we want to do is we want to combine these two recursive calls, but this recursive call returns a nested list where the elements are the possible subsequences where we don't include the first element, and this nested list are the elements where we do include the first element. And so both of these are both nested lists, right? Both of these are both nested lists. So how do we combine the two nested lists? Nested lists are also lists. So we could just add them, right? So first of all, we have to return something, right? Also, the function will just return none. And we want to add two of them. So what we want to do is we want to add subset, right? So this is the case of, okay, let me write the pseudocode first. So we want to return exclude plus include, right? And so exclude is basically just subset because we defined it already and we can just use it straight away. So subset, I spelled that right, cool. So how do we get the include part, right? So now let's look at what we wrote here. Well, we see that, well, include is basically the output of calling insert into all, so the function we defined here, where the first argument is the first element, and the second argument is basically the nested list, where the elements are basically the cases where we do not include the first element, right? And so if we want to think about a concrete example, we have this right here, where this is basically this, but in the front we add one, right? And so we could just write that out, right? So we're going to call insert into all, right? And the first, remember, the first is just going to be, the first argument is going to be the first element. How do we get the first element? Well, getting the first element, we can use list indexing, right? So we index the first element, we get the first element, very good. And then we want to get the case where we exclude it, right? And we have a variable defined here, so we can use it twice. And so let's just put it in here. And so over here, we have the case where we exclude the first element, and over here we have the case where we include the first element. And so these two combined, added together, gives us a exhaustive list of all the total, gives us an exhaustive list of all the possible subsequences of S. Cool. So now we have the recursive call down. Now we have to think about this part, right? This is going to be our base case. Now we have two ways of thinking about this base case. The more common way is, well, what is the most simple instance of the problem I'm trying to solve? And so what we can do is we can think about, well, if I call Subseq on an empty list, what should we return? So what are the possible subsequences of an empty list? Well, nothing, right? It's literally just the empty list because there are no elements we can choose from, and so that's all we're going to return. And so what we're going to return is not just the empty list, right? So let me write this down before we write the code. So base case now, we're thinking about the base case. If S is equal to the empty list, well, what do we want to return? So note that subsequence or subsec, this function, always returns a nested list. And every element in the nested list, every element in this nested list is a list which contains the possible subsequences. And since the only possible subsequence of the empty list is just the empty list, what we return is a list of which inside contains the empty list. So that's what we return. And so that's basically just our base case. So let's just put that in. If S equals to the empty list, then we return a list containing the empty list. All right, and another way you can think about this is, well, what do my recursive calls tend towards, right? So over here, we realize that, well, our list is becoming shorter, right? Because we choose to either include the first element or not include the first element. But either way, our recursive call is called upon a shorter list, right? So if we're shortening the list, every step we call, we want to have a place where we stop shortening the list, right? And if the list is empty, that is a good place to stop shortening the list. So those are the two ways we can think about the base case, and that's all for this problem.